So the next point that we have down here is how do we go about naming the main chain if there was more than one double or triple bond? And so in this case over here, we need to put in a di in the tri, but instead of putting it at the very beginning of the name, we actually put it in front of that ending "-ine" or "-ine". So if we were to take a look over here as an example, and I'm going to be writing the following. So over here, we take a look at this chain. We have a 1, 2, 3, 4, 5, 6, or going backwards, 1, 2, 3, 4, 5, 6. So they both are located in the same location. So this is a 6-carbon chain with 2 double bonds present. And so in this case over here, we know that it's going to be a hexene because there's going to be 6 carbons. And if we were to take a look at the location, this first double bond is at the location of 2, and this double bond over here is at the location of 4. So what I will be writing in front is to the identity of where those double bonds start. So it's going to be 2, 4. And so I'm going to have my hex, but it's going to be hexa. And then I'm going to be writing di for 2 and then ine. So this is a 2, 4 hexadiene. So if I was to give you another example over here, now I'm going to have the following: 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go backwards: 1, 2, 3, 4, 5, 6, 7, 8. Again, if you take a look, this is going to give you the smaller combination going from left to right, so 2 to 3 and 4 to 5. And so in this case over here, there's 8, so there's an oct. So there's going to be a 2, 4, and this will be octa. And then because there's 2, there's going to be diene. So if I was to give you one final example for having multiple bonds in a carbon chain, I could give you this one. And so in this case over here, if you were to take a look, I'm going to list the number of carbons, so 1, 2, 3, 4, 5, 6, 7, 8, or going in reverse, 1, 2, 3, 4, 5, 6, 7, 8. So now we would take a look. We have a 3 and 4, and we have a 6 and 7 in going from left to right, whereas going from right to left, I have a 2 and 3, and a 5 and 6. So which direction will be better? So again, the same process arises where we want to try to give it the smaller combination numerically. And so in this case, going from right to left is going to give us a smaller combination. So this triple bond is going to be starting at the 2nd carbon, and this triple bond is going to be starting at the 5th. So what I will be writing is a 2, 5 dash, there's 8, so I'm going to have an octa, but in this case, it's going to be a diene. And so in this case over here, you're beginning to see that there's a lot of sort of repeats of the different types of rules in the way that we go about naming our molecules.